Okay, starting section 59, I just want to go back over what the rational exponent property means. They give it to us like this. They say a to the 1 over n power is the same as the nth root of a to the first. Okay, so really take a look at how that's being transformed. Notice my base is the same both times. The denominator turns into the index. The numerator stays as the exponent. So I just wrote a couple others here. A to the 1/3. My a stays as the base. My denominator becomes the index. So now I have a cube root of a to the first. The numerator is still the exponent. So this guy here, the cube root of a to the second. That's how we rewrite powers to radicals. Powers to radicals, okay? All right. All right, so we start off with example 2, and they give us the 5th root of 243 x to the 10th. And gosh darn, I did not bring my calculator in. Okay, so the only way we know best of how to break down a radical is to tree method it, okay? So I'm going to tree method. I'm going to take 3 out. That'd be, what, 81? I'm going to take 3 out again. That would be 27. 3 out gives me 9. 3 out gives me 3. That's prime. Now remember, this is a 5th root. So I'm looking for a group of 5s. 1, 2, 3, 4, 5. Awesome. So this means this is a perfect 5th power. So the 3 gets to come out front. Now let's take care of our x's, or our variables. Now remember, with variables, you're telling yourself they have to come out in groups of 5. So this is almost like dividing. Like I always say, mom says you can go to the party if you have a group of 5. So there are 2 groups of 5 in there. Nobody was left out. Nobody had to stay in, so nobody is left under this radical. Okay? Nobody is left under this radical. Now let's do, like what if we did 32 a to the 13th, b to the 7th. And let's do a 6th root this time. Okay, so again, let's tree method it first. 2, 16, 2, 8, 2, 4, 2, 2. Now remember, I need 6. 1, 2, 3, 4, 5. Shoot, nobody gets to come out there, okay? So the 6th root of 32 cannot be broke down. But now let's look at variables, okay? 13 divided by 6. Well, 2 groups of 6 could come out, but that poor little, whoops, it's an A, not an X. But that poor little 13th one, he didn't have a group to go into, okay? Same with your B's. A group of 6 could come out, but that last B, he didn't have a group to go into. Now, I told the Algebra 1 kids, you can easily check yourself on this because remember, if they're out here, they represent a group of 6. So you have 2 groups of 6, that'd be 12, plus the 1 left inside, 13. You have 1 group out here, so there's 6, plus the 1 you have left inside, that's 7. Okay? Now, it gets a little more complex when you're dealing with fractions, and they give us the 5th root of x to the 5th over 2. Okay? Now, I just go ahead and immediately write this as this. I break it up into two radicals. Okay? Okay. Now the top is easy because remember mom says they have to come out in groups of 5 and there are 5. So that radical goes away. Okay, no one is left inside. All right, but then we know 2 is prime. So even if I tree method this guy, I still have this 5th root of radical and I can't have a radical in the denominator. Well, remember in the old days when we had a square root, it was no big deal. We just took the top and the bottom times the root. But that's because I was trying to create a square. So repeating a number was like creating a square. So if you think about it here, you have 1, 2, and you need to create a 5th. So just like these guys that came out for the party, mom says there has to be 5 2s to be able to come out. So I need to multiply by whatever is going to make 5 2s. So I need 4 more 2's to be able to get him out of that radical, meaning to get rid of the radical so that I don't have it in the bottom. And remember, whatever I do to the top, I have to do to the bottom as well. Well, 2 to the 4th is 16. So now I have x 5th root of 16 on top. Remember, there's no use of even tree methoding him because remember, we only had 4 2's, so you know nobody's going to come out. All right, on the bottom, however, now we have 2 and 2 to the 4th. Now we have 5 2's on the bottom. So it's like these cancel, and I'm just left with that 2 on the bottom. Okay. All right, now remember, these can't cancel because he's in a root and he is not. Okay. Now, they go on to talk about that our other rules are the same. Remember our power song? So if you have a negative, it goes to the bottom. If you have a 0, the answer is just 1. Multiplying powers, you add them. Dividing, you subtract. Power to a power gets multiplied. Okay, and remember, if you have a quantity raised to an exponent, you're going to distribute that through. So they remind us of those pieces. Okay, and that's what they're doing at the top of the page here. They're saying multiply powers by adding exponents. That's what they did. Then go ahead and break that down. We know 1/2, remember from right here, 1/2 would mean the square root of a to the 1st. So in this case, sorry, that's probably making you a little seasick. Okay, so here, 64 1/2, that's the square root, they don't have to write the 2 there, of 64, which is just 8. So once they did the property, then they broke it down. Same way here. Divide powers by subtracting. Well, that gave them a negative, which then moved him to the bottom. Then what does a 4th power mean? 1/4 power. That means the 4th root of 16. Now we kind of start to panic because there's a radical in the bottom, but if I tree method him out, I would find out he's perfect. The 4th root of 16 is just 2. Okay. Power to a power gets multiplied. 10 times a 5th would be 2. So then 12 squared is 144. Distribute that exponent to everybody. Then you have the cube root of 27. He's perfect. The cube root of 125. They're perfect. We should know that from our powers list. Okay. The reason why they work on this stuff is because then they want us to go ahead and solve. And remember, we use inverse operations to solve. So if I have x to the 1/3 power, I can cancel that out by raising it to a 1/3 because a power to a power gets multiplied, which canceled those out. And then I just raised that other side to that power too and got that x by itself. They do the same thing up here. They have a 4/5 power. So that means I'm raising it to the 5/4 to cancel it out. So that means I'm going to rewrite him the 4th root of 16 to the 5th. Now, you can clean this up however you want. You can either take 16 to the 5th and tree method him, or you can take the 4th root of 16 and then raise it to the 5th power. I choose the 4th root of 16 because he's perfect, and then I can raise him to the 5th. Okay, and they go ahead with that on C as well. 5 is the same thing. Example 5 is the same thing. It's just a real-life situation. They give us this formula, and they say that y is the side length and v is the volume. So if they give me a side length of 7.5, I'm just going to sub it in for y, and that's what they did here. And then how do I get rid of a cube root? Well, they rewrote it as a rational exponent, but guys, we know that. Getting rid of a cube root would be like cubing both sides, and that's what they did.